Good afternoon, ladies and gentlemen of Precalculus. Today we're going to be looking at real-world applications of parametric equations. I want to tell you, before we get started on this one, I want to tell you a little story. Is about 3 years ago, I went to a teacher training session in Richardson, Texas, and it was from my school. It was Region 10. Which is the educational organization that handles this area of the public schools. So I go up there, and one of the people in the class was an administrator from the academic support people, and we were talking about what I taught, and at the time I was talking about teaching pre-calculus and some of the things we were doing. And he talked about his main hobby was archery. I don't know if any of you have archery as a hobby. You like that?
Yeah.
Okay. Shooting arrows. And I told him what I did with parametric equations. And I told him how that the parametric equation can really figure out the path of the arrow, because he was trying to figure out if he could fit an arrow into a certain space. And so I showed him on a calculator, in fact that kind of calculator, how it could be done. So he thought that was really neat. So these things do have real world use. Simulating a foot race. Ben can sprint at the rate of 24 feet per second. Jerry sprints at 20 feet per second. And Ben gives Jerry a 10-foot head start. And so they give you two equations right here, or a parametric equation, and then it says find a viewing window to simulate a 100-yard dash. And so we can go to our calculator and put 20t here. Let's go to, I need to go ahead into parametric mode, right, don't I? And so we come right here and we put 20t, right? And then here we have, the second one we have is 24 minus 10, right? And also we have y1, y2. So 24t minus 10. So that's 3.
Would we not put in the x2? Oh yeah.
24, was it 24 minus 10t, or is it 20?
Minus 10.
24t.
T minus 10. Okay, thank you. And we go to 5 like this. Okay, now it says, why do you think we have one equation that has a y1 of 3 and the other one has a y2 of 5? Why is that the case? Yeah, we'll talk about that in a minute. But let's go ahead and it says find an appropriate viewing window. So what would be an appropriate viewing window to go ahead and track a 100-yard race? Okay, what are the units? What are the units for how fast they're running?
Feet per second.
Feet per second. So are you sure you want to go to the 100 here? No, you want to go to 300, don't you? So you want to go to 300 right here. So here is our viewing window, and we know that we are at y2 and y1, so we know that if we go to 10, we should be able to get that window. So you make sure you have everything dimensionalized right. And then once you have that, you can graph. And what's wrong with this graph?
It's not showing.
Right now.
Okay, it's not showing the whole race, is it?
I just have 2 lines.
So let's go ahead and look at, we have to fix that. Another thing, I'm looking at it gray. This is grayed out kind of. So I'm going to want to do this instead to help. Yeah, that's going to affect things, I think. Okay, so that's a little better. But what, shouldn't we see the whole race? What do we need to do? Well, we need more time. We need more time to cover the distance. So make sure you have it lit. I'm going to put here 12 seconds. I don't know if that's going to take. Yeah, I still didn't quite get it. So I'm just going to go ahead and put 20 seconds. Just to be sure. Okay, so now we've gone, they both have finished the race. So let's talk about which is which and how to analyze. So we have here is, it says t starting at t0, and they do give a t-step of 0.05, so we're going to change that. So we go back here and we t-step 0.05, that's our new t-step. So here we have this, right? So the blue one is going to be Ben, is that right? Or let me see how they worded it. Jerry, so this one here is Jerry. So Jerry is the blue one, right? And Ben is here, isn't he? And then, so now we've graphed simultaneously, haven't we? So here's the graph right here. Is that good? Now you probably see the same thing, except probably your calculator may not be in color, but otherwise it's the same thing, isn't it? Jana's is probably in color. Isn't it in color, Jana? I bet Jana feels special knowing her calculator's in color, like I do. Teasing Jana. All right, and then it says, so now we have done this, right? We have done this in our calculator, and now we're asked the question, who's ahead after 3 seconds and by how much? How do we find that out? We come here, and how do we find out who's ahead and by how much? What are you going to do with this calculator? Which button are you going to trace that's going to take you there? Somebody said it. Somebody said trace. Yes. And what happens is I got a plot turned on up here. I'm going to turn that off because that's messing me up. Come back to graph. And yeah, trace. Who said trace? You said trace? Very good. And so we're going to trace. So who's ahead after 3 seconds? So we can go to 3 seconds, can't we? So let's go to t equals 3. So at 3 seconds, this guy here that's Jerry, isn't it?
Yeah.
So Jerry is at 60 feet. So after 3 seconds, or I could put it differently, or I could say at 3 seconds, Jerry has gone 60 feet. Okay, how do we get to Ben? You have an idea how to get to Ben?
Trace.
So we do is put the up, who said put the up arrow? Somebody did right, put the up arrow, right? And so here we are, same time, but what is the distance? 62 feet, right?
Yeah.
So at 3 seconds, Ben is at 62 feet, right? So who's ahead after 3 seconds and by how much? Ben is ahead by 2 feet. So that's it. So really, if you look at this thing and just kind of be open-minded about it, you can set up windows that'll figure out these kinds of problems. What I want you to do now is go to problem 38. And problem 38, we're given 2 functions here, and we're given 2 windows here. I want to tell you something that I recommend though. For this, it says y1 equals 3 and y2 equals 3. My recommendation is to make y2 equal to 5. Why would I want you to do that? Why should I say instead I want y2 to equal 5 instead of 3? I want you to be able, it'll help you to see better, I think, where they are. If you put them right next to each other, you're not going to see what's going on as well. So I want you to do that one. I think you can leave your T step at the same time. And they give you this viewing window is really, I think, a good viewing window. Has anybody ever played Capture the Flag? You've played it before?
Yes.
Were you in Boy Scouts?
No.
You weren't? That was really a Boy Scouts game. When I was a scout leader, that was the big game at night. You'd play Capture the Flag and you hope somebody wouldn't get injured.
Did you play?
I played too, yeah. And I never got injured, but I had a scout once who broke a collarbone playing Capture the Flag, yes. With the window? Okay, 10 t minus 0.1. They're really, what you should do for this window, it says 0 to 100, right? Right? So they give you that. 0 to 100, and then here they say -1 to 10. So that's good. I think your T-step is probably good as it is. And then you go to your equation. I'll make sure I have it right here. We have 10 times quantity t minus 0.1. And over here, you have 100 minus 9t. So now everything's in place, right? Can you notice over here on this top one, t is positive, but then over here, t is negative?
Yeah.
So now we have, so where is going to be the center of this that they need to contest? Right here. And so the blue one is going to be the first one that it's going faster, but hesitated a little bit. And the one from the right is going to be the blue one, the red one on top. So how do we figure this out? Trace, right?
My window does not look like that.
Does not?
No.
I'm going to trace right over. So here is the faster runner. So the faster runner takes takes 5.1 seconds to get there. And over here, at 5.1 seconds, what happens here? This one here, so 5.1 seconds. So 5.1 seconds, the blue guy is right here, but the red guy is where?
54.1.
4.1, right?
So he's 4.
Are you still having trouble with the window? You are?
Mine's not showing T. It just shows what? Yeah, it's showing.
So you want to get here, so you want to make this 100. You see? Right here, when it's here,
Complicated.
X minimum is 0, X maximum is 100. You see that? So I don't know if that's why you put it on. And then Y minimum, let's say -1. The maximum is 10, Y maximum is 10, so that looks good. So that, everything looks good, you see here. Yeah, so this maybe should go that way. Here's the first one this way, and the other one should come more like this.
Okay, so that's working.
I think so, then try trace. No, I'm getting 4.1 feet away, right?
Mine's not showing T. Oh yeah, 4.1.
Here's a, you know what?
Yeah, then it's on the
Is this your calculator?
Yeah.
It's not showing the T.
No, mine's not.
Yours isn't showing T. Yours is showing T, isn't it? Is yours showing T?
It was just a second.
It was?
I don't know.
The trace. There's a T right here.
Oh,
Right, boy.
God.
What's the question?
Are you serious?
Okay. Who else, anybody else, are you okay now?
Yeah.
What about you, Karina, are you okay? Jane, are you okay on yours? Does it help having the color? I know, I think it does.
Well, mine was being weird for me,
Are you okay, Ryan, on this now?
I think so.
What about you? Are you okay? Are you okay? Are you getting something like this?
I mean, yeah.
There's hesitation in your voice.
Yeah, close enough.
What do you get?
Mine looks different from what yours is.
Let me show you. Probably won't take what it is on kids, because you don't have enough time. But you probably have enough time for where it is,
Is there?
because you have that much time, so you're not getting the whole way across it, Diane. But probably still works, because at least you're getting it halfway. So you have enough time. So Jana's she has like 6.28 seconds default value. I'll show you what she had.
2 weeks and 3 days.
Including this.
Well, yeah, because.
Yeah, I'll show you what,
Graduation, 2 weeks and 3 days till we graduate. Because graduation's on a Thursday, I think.
Yeah, so excited.
Mr. G, do you know when the last day of school is?
Yeah.
yeah, I sure do.
That's not
I'll
weird.
tell you in a
So it
minute
comes
here.
along graduation.
Okay, this is what Jana had in hers, I think.
Yeah.
And so you graph, and the thing doesn't go the whole way. But is this still enough to answer the question? Yeah, because you get at least this far. If you trace, you're still going to be able to get here to the center, right? So here's the center, x equals, oops, x equals 50. So there's x equals 50. And then you can go here, and the thing by going like this, it changes the same time. So you can see that he's 4.1 feet away from the center. So that's what it is. Okay, graduation, school. What's happening is we have this week, and then next week, and then the week after that is a shortened week. On the 17th is a regular school day, and the final schedules, I think, start on the 18th, or is it 19th and 20th?
So seniors don't get out earlier than everyone else?
Well, seniors have their own schedule. They won't get out, but we have other activities you're going to be doing that week, starting the 17th. So that's what's going to happen to you.
Our first activity is this week. It's the team that is here.
Yeah.
That's the AP test day, isn't it? Wednesday.
Okay. I want to do one more problem on here before we get to parametric equation sports problems. And it's going to be this one right here.
For seniors.
Okay. On problem 39, they're not giving us an equation, are they? So we have to look at the equation. And so it's using an equation to model the height of the containers during free fall. And they don't give you something. Do you know the function of time when something is dropped, acceleration or position due to force of gravity? Well, position is going to be negative 16t squared. So it's going to be, we'll put an x of t equals negative 16t squared. Has anybody ever seen that? We've seen it in this class. If you've been in this class, especially first semester, you've seen it, because we do talk about that. Okay, so what happens is you're starting out at 1,000, so the height, so it's going to be y equals 1,000 minus 16t squared. And that's going to be modeling the height of the containers during free fall. And then x equals, what do you want x to equal? X is not going to change. X can equal 2. And so you're going to see y change, but not x. And it says, let's go ahead and put that in our calculator. So I'm going to clear, Okay, I'm gonna put x equals 2. I put 1,000 minus 16t squared. And then our window is going to be an issue, because if we go to window right here, you're not going to see anything, are you? Well, let's go fix our window and t-step and everything. Well, we know we're going to drop over a distance. I don't know how much time it's going to take, but I'm going to give myself 20 seconds. T-step, we can leave the same. X max, well, we know that we only have x equals 2, so we can go 0 to 5. What about our y scale? What does our y max have to be? It has to be over 1,000, right? So I'm going to make that 1,100. I'm going to y scale at 100 here. So now we have a window where we really had to change the y, didn't we? And then we graph, and we see the drop, don't we? So here it is. And now we can go back to the question. It says use parametric mode to simulate the drop during the first 6 seconds. Okay, so after the first 6 seconds, let's do that. We go to trace, and we can go down first 6 seconds, can't we?
Yeah.
2, 3, 4, 5, 6. So now we've traced. So it dropped from 1,000 feet to 424 feet off the ground. And then we're asked, so we've done that. It says after 4 seconds of free fall, the parachute's open. How many feet above ground are the food containers when the parachute's open? Where do we go for that? Up back to what? 4 seconds. So how many feet above ground are we? 744. So 744 feet above ground. Okay, that's as far as I want to go today. Tomorrow we're going to start on, I want you to keep your paper, we're going to start on something called parametric equations, sports problems. And that'll, we'll just go tomorrow. Okay, probably starting on,
Are you going to take that down?
tomorrow we'll probably start on problem 43, where we're going to go tomorrow, okay? Thank you.
Sure, anybody?